Okay, so we've got a question here about projectiles. So we're starting with our particle which is launched from here with a speed of 23.8 meters per second. And we know that it's at an angle of psi above the horizontal, and we know that tan psi is 15/8. So as soon as I know that, I need to work out what cos psi and sin psi are, because I know I'm going to need that in later questions. Well, if tan psi is 15/8, that means that my opposite of my adjacent is 15/8. So my hypotenuse must be square root of 15 squared plus 8 squared. So 15 squared plus 8 squared gives me 289, and my square root of 289 gives me 17. So using Pythagoras, this tells me that this is 17. So I can now say that sin psi is 15/17, opposite over hypotenuse, and cos psi is adjacent over hypotenuse, which is 8/17. Okay, so what we're saying is that the ball launches up and comes down to the ground. So the first thing I'm going to do is I'm going to resolve horizontally, I'm going to resolve vertically, and I'm going to find the time taken for it to hit the ground again. So, using a suvat, I know that the height above level ground is 0. I know the vertical component of my initial velocity is 23.8. Sin psi, because they're looking at the vertical height here, which is 23.8 times 15/17, which is a vertical component of 21 meters per second. V I'm not interested in. A is minus 9.8, and T is what I'm looking for. So I can now find time using S equals ut plus half at squared, and 0 equals 21t minus 4.9 t squared. Factorising that, I get 0 equals t lots of 21 minus 4.9t. So t equals 0, or 21/4.9. 21/4.9 gives me 4.29 seconds. I'm now going to resolve horizontally to find the horizontal distance travelled in 4.29 seconds. Well, the horizontal velocity is 23.8 times cos psi, that its velocity, times the time, times 4.29 seconds, and that's going to give me my distance. So 23.8 times 8/17 times 4.29, and that should give me an answer of 48 meters. For part B, I'm again resolving vertically. The maximum distance, the maximum height is h. U is the same as what we had in the previous question, it's 21. V is 0 because it's instantaneously vertically at rest. A is minus 9.8, and I'm not interested in t, so I'm going to use v squared equals u squared plus 2as. So 0 squared equals 21 squared minus 19.6 h. So h equals 21 squared over 19.6, which gives me 22.5 meters. Okay, I'm going to go over here for part C. So again, I'm going to resolve vertically, and I know that S equals 20, my U equals 21. My v is what I'm trying to find out. My a is minus 9.8. And my t, I'm not interested in. So again, using v squared equals u squared plus 2as. I've got v squared equals 21 squared minus 19.6 times by 20, which gives me 21 squared minus 19.6 times 20. Gives me v squared equals 49 and v equals 7. So it's travelling with a vertical velocity at 7.9 meters per second. If I resolve horizontally, I know the horizontal component is 23.8 times 8 over 17. It's constant, it's not affected by acceleration, 23.8 times 8 over 17, which gives me 11.2. So when it's at a height of 20 meters, it's travelling with a vertical component of 11.2. It's either travelling, if it's going upwards, travelling upwards at 7 meters per second, or travelling downwards 7 meters per second, doesn't matter which. And so, using Pythagoras, I can say that the speed is going to be square root of 11.2 squared plus 7 squared. Which gives me a speed of 13.2 meters per second.